Okay, so first thing for this chapter is electric field. We gotta know how to draw the electric fields for a single charge and also two charges together. Right, so how do we draw, like, what's the direction of the arrows, Isabel? The arrows always point from where to where? Positive to negative, right? Very good. So always point from positive to negative. Right, the arrows are pointing away from the positive charges. Now when you draw the electric fields, there's like a specific thing that they're looking for to give you the mark. Like in the way that you draw the lines. Anyone knows? Like, you gotta draw the line in a specific way. Symmetrical, yeah, but then like, okay, symmetrical, yeah. How about the spacing of the lines? The lines gotta be closer, right? Like in the middle, you must purposely draw the line closer to represent the electric field is stronger in the middle. Right, that's for this one. Next thing, electric field lines show the direction of, yeah, like what on a positive charge? Force, right? So this one's super important. It came out last year for O-level. Electric field line of force on a positive test charge. Okay, I'll catch Raiden. Hi, Joe. Take the one that's sticking out. The second one, yeah. Catch Gerald. Okay, so what does this mean? This one's super important. It means that if I put a positive charge here, right, how's it gonna move? The field line is pointing here, right? So if I put the positive charge here, it experiences a force in the same direction as the electric field. Right? It experiences a force in the same direction as the electric field at that point. That's what it means. Now, what if I place a negative charge like here? How would the negative charge move? Yeah, towards, right? Like the negative charge moves opposite to the electric field lines. So now the field lines is pointing here. My negative charge experiences a force in the opposite direction. Right, so maybe just write down over here a negative charge move opposite to electric field.
Does it move towards the positive charge?
Yeah. Right, that's for this one. Next thing is charging by induction. In the first place, what's induction? Like, what's induction mean? Electricity is electricity. Induction is induction, right? Okay, but don't need to know lah. But induction basically means like you charge something without touching it. Like you charge it without touching it. Okay, so there's two steps to draw the charges on an earthed object. Step one, we draw the charges without the earth. So over here, like there's a minus, 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 plus, plus, plus. Step two, we erase the further side. So we go and neutralize this side, the further side. Right, we neutralize the further side as step two. What's the earth? Like, what's the earth do?
The electrons either give electrons or take electrons.
Yeah, it can give electrons to the guy or it can take electrons away, right? The earth is an infinite pool of electrons. So in this case, like, how did the electrons flow? Like into the sphere or like into the earth or out of the earth? Out of the earth, right? Like over here is positive, the earth gave the electrons and neutralized this side. Right, so we see that electrons flow from earth into sphere. Like they float like this. Okay, so the earth is an infinite pool of electrons. What if I place the earth somewhere else? Like, help me just draw this scenario over here. Let's say over here is like minus, minus, minus. Alright, so what if I place the earth over here though? Like, how do we draw the charges? Same thing, right? Like, I don't care where I place the earth. Even if I place the earth over here, Step 1, draw the charges without the earth. Step 2, we neutralize the further side. Right, so it doesn't matter where we place the earth. We always want to follow these two steps. Where's Eugene? Yeah, lor, he come, then you never come, then you never come, he come. Right, so it doesn't matter where we place the earth. Next thing is contact between conductors. Like, what do I do when there are two conductors touching each other? How do I draw the charges?
One positive on the left one and the negative one. Treat it as one object.
Treat it as just one big object, right? We just treat the whole thing as if it's one big object. So it would be plus and minus. Why can we treat it as if it's like one big object? Electrons can flow between them, right? So we just treat the whole thing as if it's one object. Okay. Next thing is charge equilibrium. I got a positive charge. I got a neutral object. What's going to happen when they touch each other?
It's spread out.
It'll spread out, right?
Equally.
Spread equally, right? So the end result will be what? Will be plus, right? So at first it's positive and neutral. It's going to see, hey, this guy is too positive. You know, I want to spread out the charges, so the charges will rearrange themselves until they all have the same charge, equal charges. Okay, do I say that, like what's happening over here? Do I say that two positive charges flow here?
You said two negative charges flow to the other side.
Two negative charges flow the other side, right? Very good. So one electron flow here, one electron flow here. This guy loses 2 electrons, become positive. This guy gains 2 electrons, become plus plus. Right? Why do I say that, you know, positive charge cannot move, right? So positive cannot move. Maybe just make a note here. Positive charge can't move. Only electrons can move. Okay, so when two things of different charges touch each other, they will like equalize the charges until they're all the same charge. So that's for this one. Next thing is charge attract neutral. Can charged objects attract neutral objects?
Yeah.
Yes, right? Charged objects will attract neutral objects. How does it happen? What's the first thing that's going to happen?
Negative charges on the left.
Negative charge on the left, yeah. Positive charges on the right, right? There's going to be induced charges on the left and right side. Over here, the left side, negative get attracted to the positive sphere. So the negative charges gets attracted to the positive sphere, and over here on the right side, the positive charges get repelled by the positive sphere. The right side, the positive charges get repelled. Right? Which one is stronger, attraction or repulsion? Attraction is stronger. Why is attraction stronger?
Attraction being closer, unlike charges, is stronger than the repulsion.
Yeah, right. So the unlike charges are closer together. So the attraction is stronger than the repulsion. So attraction stronger than repulsion. Repulsion because unlike charges are closer. Okay, this one's super important. Always commonly tested one. Alright, that's for this one. Last one is charging by friction. Okay, this. Right. So last one is charging by friction. What's the conditions for two things to be charged by friction? They got to be insulators, right? They got to be two insulators. So the idea of charging by friction is that when you rub two things together, the electrons will transfer from one guy to the other guy, right? So like you wouldn't know which one, the question will tell you. For example, the question say that the electron transfer this way, right? Which one becomes positive? The plastic rod, right? Becomes positive, this guy becomes negative. Okay, so when we rub two things together, they transfer electrons. So that's just a short summary of the static electricity. It's like pretty much all you got to know for this chapter already. All right, so right now we're going to do the quiz.